Hello friends, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 6 of a unit motion in a straight line. Let's begin with this class. Today's topic would be the graph. In this class we are going to learn about two different aspects of a graph. The one topic would be the slope of a graph and another topic would be the area of a graph. So let's begin with the first topic. It's a slope of a graph. What it would be? Let's say this is y-axis and this is x-axis. We don't know at this point of time that what y represents, what x represents, but there are two certain quantities, and let's say we have plot them up, and the things would look like this. Now let's take a random points. Let's say suppose a first this is point and its correspondence value of an x, it's an x1, and its corresponding value on the y-axis, it is a y1. Let's take this point. This corresponding value of this point, it's an x2, and corresponding value of this x2 on the y-axis would be the y2. So if I take a ratio on the y-axis quantity to the ratio on the x-axis quantity, can I say it as in delta y divided by delta x? Yes. So how could I take a delta y divided by delta x? Definitely your answer would be, sir, you can take y2 minus y1 divide by x2 minus x1, and if you can do this, this is successfully done. Yes. So this quantity, it's an delta y by delta x. This quantity delta y by delta x, this is the slope of a graph. Understand? Yes. What is slope? It is the ratio of the quantity on the y-axis of a graph to the quantity on an x-axis of graph. So how could I find out slope of a graph? We have a three different approach. A first is delta y, it's a difference of y-axis, divide by delta x, it's a difference of x-axis, and I will take a ratio of this delta y by delta x. A second feature or a second option to find out the slope is, if this differences are very small, if this differences are very small, I can write it's a dy by dx. This is the second option. And third option is, I can find out a tan theta. I can find out the tan theta. Now how could I calculate the theta? You need to understand that when in physics we are going to measure an angle, we must be starting with the horizontal axis, and I need to calculate an angle by having a motion in anti-clockwise direction. We always considered in physics anti-clockwise direction as a positive and clockwise direction as a negative. So this is my angle theta. I need to calculate this from the x-axis, which generally we take as a reference axis, and then moving in the anti-clockwise direction. So this is tan theta. Slope of the graph would be denoted as small m. Small m is the symbolic representation to represent the slope. So let's summarize this. What is slope? We just take a ratio of the y-axis quantity to the x-axis quantity. Now how many options do I am having? I am having three options. First option would be the delta y by delta x. Second option would be the dy by dx, and third option would be the tan theta. Now let's check which are the different kind of slopes can I have. Let's say this is y-axis, this is x-axis, and this is the plot for y versus x. Now I want to get an information about the slope of this graph. How could I? So first tell me, this is an angle theta, this is an angle theta. This theta is varying or it is fixed? You must say, sir, that, sir, an angle theta is fixed, an angle theta is fixed. So when an angle theta is fixed, that means that means this graph represents constant slope. Now one more information. Does it have a positive value or negative value of tan theta? Does it have positive value of negative value? Yes, it is a positive value here. Tan theta is positive. So slope is having constant and positive value. Yes, you must remember this. Now let's look at one more option. Let's say this is y-axis, this is x-axis, and straight line will look like this. Straight line will look like this. Now what is the slope of this? So if I make an angle theta, it would be look like this. As I said, we always considered an angle theta from the x-axis, which we generally considered as a reference axis. Yes, here theta is constant. So slope is constant. Here theta is constant, slope is constant. But let me know that whether it would be a positive value or negative value. Yes, you observe it correctly, as theta is obtuse. So slope is constant, that is for sure. But it must be having negative value. So this is not a decreasing slope. Please, this is not a decreasing slope. This is a constant slope, but its value would be having a negative value. I hope this is clear. This is not a negative, this is not a decreasing slope. This is a slope having a constant value, but that value would be a negative. I hope you understand this. Are you sure? Okay, let's move on and look at new slope. Let's say this is y, this is x, and a line would look like this. A line will look like this. If I want to find out the slope, if I find out the slope, then can I write like this? This is delta y by delta x. Now if I take two different correspondence of particular value, let's say this is one of the value and this is x1 and this is x2. Now here, as it is a straight line, it can have only one value. This is y1. So even at this point the value of y would be y1. Even at this point value of y would be a y1. So this would be y1 minus y1 divided by x2 minus of x1, and this would be converted to a zero slope. This would be converted to a zero slope. Are you clear with this? Yes, yes. So this graph represents zero slope. This graph represents zero slope. Are you done with this? Are you sure? Are you sure? Okay, let's look at the next. Let's say next situation would be something like this. This is y-axis, this is x-axis, this is y, this is x. Yes, and and a straight line would look something like this. Something like this. Now what is the slope of this? What should be the slope of this? Tell me, what should be its slope? So if I take a value of it, here it is a straight line. Let's name it as an x1. Let's name this symbol two different name. It is a y2, this is a y1, and let's find it out the ratio of these two quantities. It is a delta y by delta x, so that would be y2 minus y1 divide by it is an x1 minus of x1, so this would be y2 minus y1 divide by 0. Now what would be the slope? Yes, it is an infinite, so we can write like this: a slope of this graph will be infinite. Slope of this graph will be an infinite. Have you done up till this? Yes. Are you sure? Okay, let's move to the next cases. You must remember each and every case. This will help us to analyze the situation. Let's say this is x, this is y, and in this time situation would be something like this. Yes, this is the situation. Now tell me, what should be the value of a slope? So how could I find it out? How could I find it out, the slope? So what we can do is I can make a tangent, and through that tangent I can find out the relative value of an angle theta, whether theta is increasing or decreasing, something like that. So let's do this. Let's select this as a 1 point, and let's try to make a tangent over here. This is the first situation. Now let's take some more point. This is the situation, and let's make a tangent over here. This is the second point, and let's take one more point over here. This is the third situation. So if I make an first angle here, this is theta 1, this is theta 2, and this is theta 3. So by observation, what you can observe, that theta 1 is less than theta 2 is less than theta 3. That means if you are moving towards the y, your theta is increases. So as theta increases, so slope also increases, which means this graph represents increasing slope. That means value of a slope will be increasing as soon as time is going. Your value of the slope will be increasing. This is what it represents. And then last, This is y-axis, this is x-axis. A thing would be look like this. Again, what you need to do, yes, you assume it correctly, you need to find out let's say certain points from where we can get a rough approximation that what happens with this slope, what is happening with the slope. Let's look at these 2 points and make a tangent over here. This is the first. Let me extend this, and this would be the situation. Let's say this is the second point. Something like this. So this is theta 1, this is theta 2. Now what you can observe, what you can observe, yes, you are right, that I can observe that theta 1, theta 1 is greater than theta 2, which means slope at location 1 is greater than slope at location 2. So this graph represents slope of decreasing value. This graph represents a slope of decreasing value. So let's summarize this. Let's summarize all the situations. You just try to recollect all this. This was the first situation. This was the second. This was the third. This was the fourth. This was the fifth. And yes, this was the sixth. This is y-axis, this is x-axis. This all graphs that we have already discussed. Now you tell me, which graph represents which thing? What they represents? First, slope is constant and positive. Slope is constant and positive, yes. Second, slope is constant, but it should be having a negative value. A third situation, what was the slope? Look at this here, y remains the constant, slope is 0. A next situation, here the slope is infinite, yes. Here slope is increasing. And last situation looks something like this. What was the case? Here slope is decreasing. Slope is decreasing. So this is just the summary of all the slopes that we have studied up till now. This is all the summaries. But the thing is, why do we study all this? And what is the slope and physical significance? What is the physical significance of a slope? So let's look at the physical significance of slope. And why do we study all this in physics? Specifically in physics, why do we analyze graph up to this level? So let's say a certain graph is given which represents a distance versus time. And if we have plotted a graph, it would look like this. It would look like this. And they have asked something about the speed. They have asked that what should be the speed or something like that. So first tell me, do you have any relation which can relate speed, distance and time? Which can relate speed, distance and time? Do you have any formula? Do you have? Yes, you can say so that sir, speed must be equals to distance divided by time. Now, listen to me very carefully. Distance is on y-axis. So basically, what you wish is delta y, and time is of x-axis. So this is delta y by delta x. Now, what was delta y by delta x for us? Yes, you are correct. What was it? Yes. So, slope of this graph, slope of this graph will give me a speed. Slope of this graph will give me a speed. Are you sure? Are you done with this? Yes. So what I can write is if graph is of distance versus time, then its slope will be speed. A same way if if graph will be of displacement versus time, then slope of that graph will be velocity. Are you clear with these things? Are you clear that if graph is of distance versus time, if graph is of distance versus time, its slope should be a speed. But if graph would be of displacement versus a time, then its slope will be a velocity. Okay, how could I identify that which would be the slope? I am having a very basic formula that if I am going to divide delta y by delta x, if I am going to divide delta y by delta x, and whatever the quantity comes, it is the slope of that graph. Are you sure? Did you understand all the things that I have discussed up till now? Are you sure with this? Okay, let's move on to the next. Let's say this is a graph which represents speed versus time, and the graph look like this, and they have asked certain things. We don't know at this point of time what they have asked, but we know that they have asked about the acceleration. Now, do you have any relation with acceleration, speed or time? Basically it is a change in the speed. So what you know is, sir, acceleration is equals to change in speed, or you can say it's a change in velocity divided by time. Now what is change in speed? Can you write it is a change in the y-axis? What is time, or what is change in time? It is a delta x. Yes. So acceleration is, I need to find out the slope only. I need to find out the slope only. So what we came to know that if graph is of speed versus time, then slope of the graph is acceleration. One more thing, if graph is of velocity versus time, then slope of the graph should be acceleration. Yes. So if graph is of speed versus time, slope would be the acceleration. If graph would be of if graph would be of velocity versus the time, then the slope would be of acceleration. Are you sure with this? Yes. Yes. Any confusion? Any confusion? No. So let's look at the certain questions based on the slope only. Let's say this is one of the graph which gives me an distance versus time, and it looks like this. I am drawing one more question, but before you go through it, first you are having a time so that you can think about the first graph, that what would be its slope, what would be its slope, and what it represents about its slope. This would look like this. Now now I need to discuss about their slope. I need to discuss about their slope, that which quantity will be their slope, and and what their slope represents. Are you ready with this? Are you sure? Yes. Now first tell me, this is distance versus time, its slope will be, what is the slope of distance versus time? What is it? Yes, it is a speed. Now what this graph represents about the speed, have you remember this pattern? Did you? Did you remember this pattern? Are you sure? Yes. What it does it tell? It tells that speed is increasing with time. Speed is increasing with time. How could I know this? Because I know that through this graph, slope is increasing. How can I check it that whether it is increasing or not? Take a random points, make a tangent, plot a tan theta, and just approximate the value of a tan theta, and the things will be done. Yes. Okay, great, done. Great job. Let's look at the next question. It is a velocity versus time. Now your y-axis is velocity, your x-axis is time. If you take a ratio of this delta v by delta d, what it would be? Yes, it is an acceleration. So their slope would be the acceleration. Now tell me what it shows, what it represents for the acceleration. What does it show? Yes, you are correct. They says that acceleration is 0 for given situation. Even if you don't have any idea about the slope, you can directly know that let's say here the speed or velocity is x meter per second, and as the time passes it remains the same, so there is no change in the speed. And if speed is not changing, that means our object is moving with uniform speed or having a zero acceleration because speed is not changing. Yes. Okay, do you have a fun in this? Are you sure? Okay, great. Let's move on. Let's say this is displacement versus time, and graph look like this. You are having a time because I am preparing this question, so think over this. This is velocity, this is time, and and this is the graph that they have given. Now let's ready to analyze the slope of this. So what would be the slope? It's an delta x, let's say represent x, and delta t. So their slope will be a velocity. So let me write this. Their slope is velocity. Now what this graph represents about the velocity, what this graph represents? Yes, it is decreasing. So you can say that velocity is decreasing. Velocity is decreasing with time. So as soon as you are moving forward, your velocity is decreasing. Now let's analyze this situation, or situation number 2, what it would be. It's an delta v by delta t. Yes, you assume it correctly. This is about the acceleration. So first thing, their slope, their slope would be the acceleration. Their slope would be the acceleration. Now, what does it represent? Yes, it is an infinite slope. So this situation shows that acceleration of this object will be infinite. This is only the pen and paper situation, because in practical life we cannot have an acceleration which could lead to an infinite. So this is just the situation when pen and paper is used and no physical world is involved in this. Okay, let's look at this situation. Let's try something new. Let's say this is work done, and this graph represents displacement, and graph is representing something like this. Now what does it tell? That analyze slope of this graph. That is what they have been asked, that analyze the slope of this graph. Now first thing, what is slope? What is slope? That I can know is that it is an delta work done divided by delta displacement. Yes, delta work done by delta displacement. Now on the back of the mind, I must know that work done is equals to force into displacement. So if I divide this, I must be having an force. This must be done in the back of your mind. So slope of this graph, a slope of this graph is force. Force is the slope of this graph. Have you done up till this? Did you? Are you sure? Well done, great job. Now what can I tell about the force in this situation? I can come to a conclusion that this is theta, and as theta is not changing, it is fixed, I can say that force acting on an object is constant. Positive value or negative value? What it would be? Yes, you were right. It's a positive value. It must be having a positive value. Are you done up till this? Are you? Are you sure? Okay, let's move to the next case. Did you remember V is equals to IR? Did you? Did you remember V is equals to IR? Are you sure? Let's have a one question over there. Let's say This is V, this is I, where V is the voltage, I is the current. V is the voltage, I is the current. And we have been given a two lines, two different lines for two different materials. This is material number 1, this is material number 2. I have been asked that find out which material is having higher resistance. I have been asked this. Find out which material is having an higher resistance. So before to know about the resistance, what should be done in back of the mind? I must relate V, I and resistance. Do I have any corresponding relation within this three? Do I having it? Yes, it is a V must be is equals to I into R. So if I know this, I even know that R must be is equals to V by I. This is the rough work of my mind. This is the rough work of my mind. So I must know that resistance is slope of this graph. Resistance is slope of this graph. Now I need to find out the higher resistance. So if I know that which slope is higher, I will easily conclude that this material must be having a higher resistance. Now how could I find out the slope? What are the possible options am I having it? Yes, one is the delta y by delta x. Let's write it down here. Delta y by delta x. Another is the dy by dx. And the third would be the tan theta. I am having in this three options, delta y by delta x, dy by dx, and the tan theta. Which one would be the useful at this point of time? Which one? So I can easily find it out that tan theta will work for me. Let's say this is as a theta 1 and this as a theta 2. As I can easily see it that the theta 2 would be greater than theta 1. So as theta 2 is greater, I can write like this: tan theta 2 must be greater than tan theta 1. Tan theta 2 must be greater than tan theta 1. So resistance 2 must be greater than resistor 1. So resistance of second material is higher as compared to the resistance of first material. Yes, you understand the complete situation, why we study this slope and why we analyze the graph. What is the need in this situation? Are you done with this? Are you sure? Did you understand these things? Are you any difficulties? Is there anything? No. So let's look at the certain graphs of practical reality. Let's look. First, this is the graph. This graph represents position versus the time. This is the position and this is the time. Now you need to analyze this graph and tell me what would be the situation. Now let's say what would be the velocity. So I know that velocity would be equals to delta x by delta t. So slope of this graph would be a velocity. Now what this represents? Yes, that velocity, that slope of this particle, that I can say that slope of this situation is 0, and slope of this graph, it is a velocity. So velocity of particle is 0. Yes, and when velocity is 0, you can say that body is at rest, it is not moving, because at this point it is at this position, at this time even it is at that position, even at this time it is at the same position, and it is not changing its position, it is not changing its position. That means an object is at rest. Yes, are you sure? Okay, let's look at the next. It's a again position versus time graph. This is position, this is time, and let's say this is theta. Now tell me, this theta is changing or it is a fix? Yes, you are right that slope is constant. The slope is constant. Positive or negative? Yes, theta is acute. Theta is an acute, and when theta is acute, it must be a positive value. Now, what is the slope of this quantity? What should be the slope of this quantity? Yes, it is an x versus t. So I know that it is a uniform velocity. Velocity of particle is constant. Why? Because slope is constant. Slope is constant. So it is moving with constant velocity. Yes. Next, it's a position versus time graph. Again the same graph, position versus time. But situation looks like this. Now tell me what the slope situating. Yes, this is showing that slope is decreasing, and when it is saying that slope is decreasing, when this is saying that slope is decreasing, that means velocity of particle is decreasing, because tan theta is decreasing. Here you can see that we have done in previous slides, that you need to make a tangent, yet this is tangent, this is theta 1, this is theta 2, and so on. So you can directly check it out that whether this slope is increasing or decreasing. Here in this case it is decreasing. Let's look at the next situation. Let's say this is the velocity versus time graph. This is velocity, this is time. Now first find it out the slope. It's an delta v by delta t. Yes, and that I know that it is an acceleration, so slope of this graph would be an acceleration. Now what does it represents? Yes, it is a straight line. Straight line, that means slope is 0. Straight line means slope is 0. That means acceleration is 0. So that's it. So did you understand the situations? If you remember all the patterns, if you remember all the patterns of that previous slide, where we have summarized all the situation, that this is zero slope and this is infinite slope and this is constant slope, constant but positive, constant but negative, you can very easily understand all the situations. Next, again velocity versus time graph. Tell me, this is theta, positive, negative? Yes, you are right, it is a positive slope, constant. Yes, so what does this slope says? That says that slope of this graph is constant, slope is constant. Now what would be the slope of this graph? Velocity versus time, it's an acceleration, so this says that it shows a uniform acceleration. This graph shows uniform acceleration. Are you sure? Yes. Look at the next situation. This is again velocity versus time graph. This is theta. Theta is acute, obtuse. Yes, you were right, it is an obtuse. And when it is obtuse, when it is an obtuse, this represents negative. If this is negative, that means dv by dt would be a negative, but it is a constant value, so it represents constant retardation, or decreasing or negative acceleration, that means a retardation. Yes, have you done with this? Ready to have a look at the next situation? Let's look. This is acceleration versus time graph. This is acceleration versus time graph. What do we call? We can say it's an dA by dt. This is the slope of this graph, as this represents a constant horizontal line. That means it is showing zero slope, and when slope is zero, That means acceleration is constant, and rate of acceleration, when I say rate, I mean I am dividing it with respect to time, and rate of acceleration is 0 because there is no change in acceleration, and that's why we say that acceleration is constant. Yes, look at the next case. Acceleration versus time graph. What does it represents? That this is theta. Theta is constant. Slope positive negative. Yes, slope is constant and positive. Slope is constant and positive. So this represents that dA by dt. dA by dt should be at tan theta and it should be in greater than 0. So this represents that acceleration is uniformly increasing with time. Acceleration is increasing uniformly. Let's look at the last situation of today's task. This is acceleration versus time. This is the graph of the acceleration versus time. Now what this represents? This is the theta, acute obtuse. This is obtuse. What they say is about the slope, that they says that slope is constant but negative. Slope is the constant but it is a negative slope. So what does it represent? It represents negative constant. That means dA by dt must be a negative. So let's wind it up here. What we have done is we have started with the graph. We switched to the slope of the graph. We have analyzed several situations, that what could be the slopes and how can we identify that this represents what kind of situation. Yes, I hope you are clear with all these things. In the next class we are going to look at the area of the graphs. So till then, just practice this kind of questions. Thank you. Good day. Bye bye. Take care.